Assalamu alaikum.
Walaikum salam, sir.
Can you hear me? Yeah. Right. So just we'll wait a minute or so before we start. Any questions in the meantime? So how's the semester progressing?
Fine, sir.
Right. So you're all gearing up towards the end now.
Yes, sir, definitely.
तो कितने courses ले रहे हैं semester में आप?
Sir, 4.
4 courses. It's manageable.
थोड़ा सा hectic हो गया था.
अच्छा.
Otherwise, it was fine.
Chilling, great. So first of all, we have one announcement. Inshallah, we'll be having a small quiz on Sunday, inshallah. 15-20 minutes ka hoga. And once again, you'll have that window of time, which is approximately 5 minutes longer than the actual duration for the quiz. So 20-25 minutes ka window hoga, 20 minutes roughly ka ye hoga. Okay, so any questions before we start? Okay. Right, so the last lecture we talked about how internet addressing is done, and we specified that internet addresses are 32-bit, and basically within that same 32-bit address, you've got two parts. You have a network or a subnet part, and then you have a host part. So you have a network ID as well as a host ID within the same 32-bit address. Now, how do you specify कि network part kya and host part kya hai? Initially, you had something called classful addressing, where the network part was fixed. So you had class A addresses with an 8-bit address, class B addresses with a 16-bit address, class C addresses with a 24-bit address. And the host ID accordingly was 8, 16, or initially 24, 16, or 8 bits for class A, class B, and class C. Then it turned out that that was fairly inflexible. So we came up with another scheme called CIDR, or classless interdomain routing. Jahan pe using a slash notation, it was possible to have any number of bits as the network ID and the remaining bits to make up the host ID. Okay. And the whole idea in this is that you've got a mechanism where you would like to have a hierarchy. So addresses which have a common prefix, have a common network ID part, have a common set of first bits, unko aap ek hi network treat karte hain. And then within that common prefix of binary addresses which make up the network part, the host IDs are different, and that is how you have within a subnet different host IDs. So is subnet ke andar you'll have the same common prefix. Is दूसरे subnet में you'll have a different but common prefix to all the hosts within the second subnet, and so on. And then these subnets are interconnected through these routers that you have over here. So the way addressing is done is that you look at the first few bits, and uske hisab se you are going to forward your datagram to the appropriate interface of the router, and that is done through forwarding tables. So we have an example here where you have a network, okay, and the network is a 132.10.1 network. Okay. So this means that this network mein ye jo 138.10.1 hai, that is a common prefix to all the hosts that you have over here. Note that network address ko aap .0 at the end likhte hain, and so you're specifying the network with once again a 32-bit address. Lekin jo aakhir mein zeros hain, that mean that they are basically all of those zeros refer to the fact that when you put a slash and then you specify कि अच्छा इसमें से network address का कितने bits हैं, तो वो जो सारे जो आपके पास bits बच जाते हैं for the host IDs, they can be anything. So अगर network address 138.10.1.0 है, ठीक है, in that case it means कि ये जो network ये जो शुरू के bits हैं जो 0 नहीं है, ये common होंगे for all the hosts within this network. And you can see over here कि host 1 has an address 138.10.1, that's the network part, and the .1 is the host address, the host ID within this IP address. And here you have a .2 hosts. The first 24 bits once again are the network part which are common. इसी तरह से दूसरा नेटवर्क है आपके पास which is a 138.10.2 network, ठीक है, and यहाँ पे this is the common prefix and you've got a .1 host and a .2 hosts over here, and these are hosts 3 and host 4. इनके दरमियान आपने एक राउटर लगा दिया and this router is connected to the internet. Now suppose that H1 wants to send an IP datagram to host 3. So host 1 host 3 को भेजना चाहता है, ठीक है. Now if you look at this IP address, ठीक है, if you were to consider this to be old addressing which is classful, so then इसको देखिए, because this number, this IP address lies in the range from 128 to 191, ठीक है, which means that the first 2 bits are 10 if you convert this to binary, which is a class B address. So class B addresses के लिए the first 16 bits make up the network part. तो उस केस में ये भी and ये भी दोनों एक ही network को belong करते हैं. So because they belong to the same network, then you should be able to do a direct addressing between them. और मसला ये है कि बीच में you have a router over here, ठीक है. So somehow this router has to be able to understand that these are part of the same network. In fact, you don't need a router. If you had this as part of the same broadcast domain, as part of the same network, then of course you could directly send a IP packet from H1 to H3. लेकिन बीच में जब आपने router लगा दिया, so now you've got इस interface पे you have a different network, इस interface पे you have a different network. So essentially you need to have some kind of mechanism to be able to relay this forward. Now, if you are using CIDR subnetting, then this can become indirect, provided of course कि आपने network ID को 24 bit specify किया. So in that case, this becomes, this network over here is 138.10.1. This network over here is 138.10.2. You have a router in between, and of course, you can route packets from network subnet 1 to subnet 2 through this router. Okay. So the question is that what should be the length of the subnet mask for proper routing of H1 to H3? Well, for proper routing, what needs to be done is you have to ensure that these two belong to different subnets, and उसके लिए ये है कि आपको कम से कम ये जो पहले 24 bits हैं, they should make up the network ID or the subnet, and the remaining 8 bits can then make up for your hosts. Okay. So any questions here? So notice कि आजकल हम ये CIDR ही इस्तेमाल करते हैं, and इस केस में although this is IP address जो कि 138 वाला है, लेकिन when you use a /24 with this, ठीक है, it works perfectly okay. उस केस में the first 24 bits 138.10.1 तक they become the network ID here, and यहाँ पे भी /24 के साथ ये 138.10.2 become the network ID, and then you've got hosts okay within that same subnet. आगे आप different hosts को uniquely identify कर सकते हैं within this subnet. Any questions here, जी? So notice it's important that you specify कि network का part कितना है, because अगर आपने इसको mask देके 255.255.0.0 किया, ठीक है, then of course both of them are going to belong to the same network, ठीक है. And when you send a packet from here to here, or you want to send a packet from here to here, then both of these have to be part of the same network. बीच में router आपके पास इस तरीके से नहीं होना चाहिए. Okay. So CIDR addressing, just to recap, IP addresses आपके पास 32 bit है. You write that as a dotted quad. Then the mask specifies कि कितने bits जो हैं they make up the network part. So for the mask, आप उन bits को ones कर देते हैं. And notice the mask has to be contiguous. I cannot have a zero in between over here or over here. ठीक है? That would not make sense. ठीक है? So the mask has to be a contiguous set of ones. And जितने भी ये ones हैं, what that will do is that will ensure that when you AND that with the IP address, okay, that will give you the network part or the subnet ID part. So the network prefix is obtained by ANDing the address with the mask, and that gives you that gives you the subnet prefix, or it's also called the network prefix. And the remaining bits are for the hosts. Hosts can span a range from all zeros to all ones. तो उतने आपके पास hosts potentially हो सकते हैं in that particular network. The CIDR notation is that you either write the entire 32 bits, ठीक है, in a dotted quad format, and /15 आप डालते हैं, या फिर जो most significant वाले हैं, ठीक है, 12.4, and you don't for sort of writing this in sort of compact notation, you drop the .0.0 over here. So 12.4/15 implies 12.4.0.0/15. So the question then is that how does a host get an IP address? Okay. Now it could be either hard coded by a system admin in a file. So you could statically configure this. आप अपने भी जो भी आपका host है उसका, if you want to find out what its IP address is, if you're working in Windows, you can go to the control panel, network configuration, TCP/IP properties, and see what the IP address of your host is. Unix में it's typically hard coded in a file by the system admin, and this is with the name of the file जहाँ पे ये hard code किया जाएगा. दूसरा तरीका ये है कि you use DHCP. DHCP is a protocol called Dynamic Host Configuration Protocol, and basically you dynamically get your address from a server. And the reason is that nowadays you have big networks, and it is not possible for one to statically configure the addresses for every single host. एक चीज. दूसरी चीज ये है कि many of these hosts are mobile, so you basically have your device, you walk into a mobile region, ठीक है, जो कि Wi-Fi enabled है, so you dynamically get IP address for the duration that you're there, and when you move to another Wi-Fi network, then of course you get a new address based upon that particular network. So your DHCP server typically has a pool of addresses, and dynamically जो भी arriving client है उसको आप एक address दे देते हैं. जब वो client चला जाता है, then that address is reclaimed by the pool. It is given back to the pool, and कोई और आता है, so उसको वही address दिया जा सकता है potentially. So rather than statically having a unique IP address for each device, ठीक है, you have a pool of addresses through which you can dynamically allocate them to जितने भी concurrent users हैं at any given point in time. So this provides much greater flexibility. It provides for much greater ease of management in terms of managing all of these IPs, because वरना जो है ना network administrator statically जाता ही रहे, allocate करता ही रहे, यानी tables ही maintain करता रहे कि किसको क्या दिया है, and so on. And also it would be because you have limited IP addresses, ठीक है, and devices ज़्यादा होती हैं, so ये उनको यानी statically assign करना is not a scalable solution. So how does the DHCP protocol work? Basically आपके पास एक DHCP server है जो कि ये dynamically allocate करेगा IP addresses. जब एक client arrive करेगा, it will need an address in this network which it is joining. So it doesn't have any address to start with. Okay? So when it joins this network, it somehow needs to send out a message and do a query. Okay? So The arriving client comes in and broadcasts, is there a DHCP server out there who could provide me an address? Okay. Now, the amazing thing is that you could have more than one DHCP server. Okay. So the server comes back by saying, yes, I'm a DHCP server, and here's an IP address that you can use. Okay. And uske baad, then because you could have multiple offers that a client receives, the client is in that enviable position ke usko ek se zyada server se response aa sakta hai. Therefore, ऐसा नहीं है कि as soon as you get the offer, yani that's it and done. Okay. There's a second step in which the client confirms that, okay, I'll take that IP address. Okay. Because you could have potentially more than one DHCP servers. And once the client confirms, then the DHCP server acknowledges that confirmation and tells him back, "Theek hai ji, you've got that IP address." Okay. Now, so the question then is that, Acha, what is the source IP for this arriving client? Source IP by default hum 0.0.0.0 rakhte hain because we don't know what the source IP is going to be. So this is a IP address jo ki reserved hai, theek hai, and that is for sources jo ki is tarah se arrive kar rahe hain. You then basically इस प्रोटोकॉल के अंदर you are reserving जो भी client का port number है that 68 and the server's port number जिस पे वो ये listen कर रहा है is 67. But what you do is you send out a broadcast packet. So this is a broadcast packet. Broadcast packets का जो IP है that is 55.255.255.255 all ones basically. So when this packet goes out to all routers, okay, it's broadcast, so everyone listens to this, ठीक है, and जो DHCP server है वही या servers हैं वही respond करेंगे, ठीक है. So a broadcast जो packet है that is received by all of the hosts within a network, and the router sort of then yani if there is a DHCP server in that network, it's going to then respond to that, ठीक है. So ये अपना IP address 0.0.0.0 कह रहा है, and it has a transaction ID, ठीक है, जो कि client बता रहा है कि this is the transaction ID that for this particular DHCP discover request. And ये जब respond करेगा, of course ये उसी transaction ID के साथ respond करेगा, so that the client knows that the offer that it's receiving is corresponding to the same discover request that it had sent out. इस case में notice कि server का IP है 223.1.2.5. So the source over here is 223.1.2.5 and the port number is 67, which is the port जिसके ऊपर originally इसने request भेजी थी. This is the address of that it says आप ये address available है. This is the address that you could potentially use. And it also says that, well, there's a lease time for this address, and that this address is available for this 3600 seconds, which you can sort of convert into minutes and hours. So ये typically घंटों के ऊपर, दिनों के ऊपर, the lease time is relatively long, for which it announces that this IP is available. ठीक है. The DHCP request, let's say you've received multiple offers, then of course you're going to send out another request, and उस वक्त तक की confirmation नहीं होती, so therefore your source IP is still 0.0.0.0, and you're sending out on the same port, ठीक है. Your destination address once again is a broadcast, ठीक है, and you are specifying it, ठीक है, I will take this address, ठीक है, I want to take this address, and the transaction ID, of course, जो है यहाँ पे ये आप, this is not a discover, so you will come up with a different transaction ID, and of course you will use the lifetime जो कि आपको offer किया गया था. And when it comes back, ठीक है, it uses the same transaction ID as your request, confirming कि हाँ जी ठीक है आप ये address ले लें. Of course, the source over here is going to be the same. And once the DHCP client receives the DHCP acknowledgement, subsequently यहाँ के बाद it's going to then start using this particular source, this particular IP, it's going to use this now for all transactions down the road. तो यहाँ पे इसको ये confirm हो जाता है, and it starts using this particular IP. Okay, so any questions in this sort of exchange? Arriving client broadcasts for a discoverer. वहां से एक ऑफर आती है, because you can have multiple offers, आप एक उनमें से potentially DHCP request वापस भेजते हैं कि हाँ जी ये confirm कर दें मुझे, and ये आपको फिर ये DHCP acknowledgement से वो IP address confirm हो जाता है. Any questions here? जी, there's a question in the chat. Yeah. Okay. So what basis does this select? Well, there is no basis for it to select. ठीक है, वो तो आपको एक IP चाहिए है. Within that, you need one IP, so you send out a request. Allocate me one within a pool. ठीक है, ठीक है. So therefore, it could be first come first serve. It could be something else. So there is यानी कोई ऐसा, there is no क्या कहते हैं hard and fast rule कि वो किस basis के ऊपर करेगा. Basically a client जब join करता है किसी भी network को, उसको IP address चाहिए, and as long as it gets an IP address, it's good to go. ठीक है. So that's how it is. Okay. Okay. So the next question that comes to mind then is that how does the network get its address? ठीक है. So आपको ये address जो है ना, network address, ये कहाँ से मिलता है? And this is an interesting sort of problem because we have global addressing in IP. The Internet Protocol allows you for global addressing. So you need coordination amongst countries, you need coordinations amongst regions. कि ये जो IPs हैं, ये कैसे map out किए जाएंगे, ठीक है? And उसके लिए very interesting. There's an organization which is called ICANN. Okay. And can you see my screen? आपको ये screen नजर आ रही है, ये वाली screen. Okay. So there's an organization called ICANN. Okay. And this is the Internet Corporation for Assigned Names and Numbers. Okay. And this is responsible for sort of globally coordinating all of these IP addresses as well as the DNS और ये सारी चीजों की जो top level domains हैं, इनको coordinate करने के लिए this is the organization. Now there is some history to this. इससे पहले you had an organization called IANA, ठीक है, which is the Internet Assigned Numbers Authority, ठीक है. And IANA जो था ये, because the internet grew out of a sort of project of DARPA, which was the Defense Association's Research Project Agency, Department of Defense की branch थी, and you had many universities sort of collaborating in the development of the protocols as well as the internet infrastructure at the time. So initially you had volunteers. People like John Postel ran IANA all the way up to 1988, and they were sort of figuring out कि अच्छा जो नई universities join कर रही हैं, नए organizations join कर रही हैं, how is this going to be done? And then of course this IANA, which was globally coordinating these addresses, this sort of merged with ICANN and so on. ICANN बाद की organization है, and under IANA you've got regional internet registries, and regional internet registries जो है, ठीक है, मुर्गियाँ नहीं है लेकिन this is what you have, ठीक है. This is the current state. पहले for example the American जो registry थी for internet sort of ARIN. It used to cover all of North America and South America and South Africa and parts of Africa as well. But now this is how it's organized, that currently आपके पास North America के लिए ARIN है, then Latin America and Caribbean के लिए you have this LACNIC, ठीक है? Then AFRINIC is responsible for the IP addresses and naming within Africa. RIPE जो है, this is for Europe. It's a French word which means which starts with the other or so. And इसी तरह से आपके पास EPNIC है जो कि इस region, हमारे region के लिए the Asia Pacific Network Information Center is responsible for all of this over here. उसके अंदर, for example, पाकिस्तान के लिए you've got so can you see this map? ठीक है जी. Okay, so that's how the sort of the globe is organized. You have these 5 regional internet registries, and then इसके अंदर, for example, हमारे जो APNIC है, it consists of 56 economies, and Pakistan को जो है ना PKNIC देख रहा है, and PKNIC is in Lahore, it's in Garden Town, but आपने कोई भी registry domain sort of register करनी है, so PKNIC is the Pakistan Network Information Center. Is what is responsible for all the domains that you have within Pakistan. So APNIC is the Asia Pacific one. It's a very interesting website. You can see कि यहाँ पे आप कैसे IP addresses, and there's this interesting material over here. IPv6 की trainings वगैरह भी है, managing IP addresses, all of that. And then PKNIC is the registry provider for Pakistan, and यहाँ पे it provides you all the details of how much does the domain name cost and so on. So हर एक registry को एक block और blocks of IP addresses दिए जाते हैं. ये फिर आगे जो है ना ISPs को वो blocks जो है ना allocate करते हैं, and that is how individual users connect to ISPs, and ISPs को जो blocks available होते हैं उनमें से वो आपको या statically, let's say you can purchase or you can lease out IP addresses for a certain duration, या फिर ये है कि आपको dynamically from a pool, वो ISPs have a certain pool of addresses, and each time you make a connection to the internet, वो आपको dynamically DHCP के through from that pool available to them एक IP जो है ना वो dynamically allocate करते हैं, and when you sort of drop the connection, release the connection, तो फिर that is sort of वो pool में वापस आ जाता है, and then it's given to somebody else who connects, and that's how with this limited number of IP addresses they manage all of the internet. ठीक है जी. Now it's interesting that the APNIC tells us that your IP address is 110.93.234.9. ठीक है, and you can do this search. What is my IP? ठीक है. And it's interesting to note कि आपको your public IP address is आपको ये specify किया जाएगा. And if you do a search multiple times, what you'll notice is that you might get a different address. ठीक है. And we'll explain in a minute कि ये कैसे हो रहा है, कि how are you getting a different address. ठीक है. So for example, if you try it out, this one over here, you're getting a slightly different address over here. The prefix is the same, you're getting a different one over here. So LUMS, for example, gets its IPs from multiple ISPs. PERN से भी लेते हैं, जो पाकिस्तान एजुकेशनल एंड रिसर्च नेटवर्क है, जो HEC के साथ रिलेटेड है. We also have PTCL, we also get them from other ISPs. So जब आप connect करते हो different वालों के साथ, तो therefore you sometimes you're going to get a different IP address depending upon कि उस particular point in time के ऊपर dynamically ये जो request गई है, ये किस ISP के through गई है, and correspondingly आपको वो IP address sign हो रहा होगा for that particular request. Okay, so any questions about about this. So you have these non-profit organizations which provide this global, they provide this global coordination, ठीक है? And उसके ज़रिए से the internet works, and that is how it's done. So you get, let's say कि आप एक ISP के साथ connect कर रहे हैं, and ISP को ये block of IPs दिया हुआ है, which is 200.23.16.0/20. ठीक है? Now, because it's a /20, that would mean that ये 16 bits and इस octet के 4 bits, ठीक है? The most significant 4 bits of this octet make up the ISP's block. ठीक है? अब ये जो .16 है, इसका मतलब ये है कि ये जो most significant 4 bits हैं, ठीक है? In this block, they are going to be 16. ठीक है? So if you work this in binary, a 16 maps out to, if I work this in binary, ये क्या होगा जी 16 in binary? So if you write 16 in binary, you're going to have the most significant bit is a 128. So 128s नहीं है, 64s नहीं है, 32s नहीं है, 16 है, ठीक है? And then yeah, so that's a 16. But can you see this chat box, man? Can you see that? Let me just enter that. That's yeah. So 0001 and then what 0000. That's the 16. अगर इसमें 4 most significant bits हैं, they are part of the network ID, तो ये change नहीं होंगे, ठीक है? So I'll have 200.23.16 में ये 4 most significant bits change नहीं होंगे. ये जो bottom वाले bits हैं, they can go from all zeros to all ones, ठीक है? इसका मतलब है कि अगर all zeros हैं तो ये 16 होगा, ठीक है? अगर ये all ones होंगे, ठीक है? So that address is going to turn out to be 31. Okay? So .16 से लेके .16 से लेके all the way up to .31 तक ये आपके पास यहाँ पे addresses आ जाएंगे. Okay? Now what this ISP can then do is that if, for example, 8 different organizations are connecting to here, okay? So what it can do is, okay, ये पहले 20 bits तो इन सब में common होंगे, and then उसके नीचे what it can do is that it can allocate a different range of addresses to each of these organizations within this. So for example, it decides that it's going to use a /23 address. Okay? So that would mean that the 23 bits make up the network ID and the remaining 9 bits make up the host IDs within this organization. So organization 1 ke liye, you're using a 200.23.16.0. Next ke liye, it's a 1001, which is a 18. Next ke liye 20, next, and so on. So you have these 8 organizations which are .16, .18, .20, all the way to .30. Notice because you're using 7 significant bits out of these 8 in this octet, तो जब ये एक के साथ आप आगे जाएंगे तो it's going to effectively be an increment of 2, ठीक है? And within this organization you have 9 bits for the host ID, which makes that you can go from all zeros to all 9 ones, and with 9 ones you're going to have 512 particular hosts जो कि हर एक organization के अंदर बना सकते हैं. And ये जो decision है कि अच्छा आपने कितने bits host को देने हैं and कितने bits network को देने हैं, depends each of these आपके पास organizations कितनी है and within each organization आपके पास hosts कितने हैं. So if you had 8 organizations and you had this network space, okay, then of course the ISP could break up its, because ISP का block जो है उसमें most significant bits आपके पास 20 हैं. Now within these 12 bits, ठीक है, what it can then do is it can further break up these 12 bits into 8 blocks, जिसके अंदर आपके पास these 3 bits over here become the identifiers for the organization. So notice कि 0001 तो common है सबके अंदर, but इसके बाद then 0000, 0001, 010, 011, ये जो next 3 bits हैं, they are making up the ID for each one of these organizations with a common 20 bits in the start. So what this ISP is doing is that it is जो इसको available host space है, उसको ये further break up कर रहा है into these different blocks for each one of these organizations, and then the organization, of course, is then limited to the least significant 9 bits to identify the hosts within the organization. So essentially what you've done is you've taken a block of 100.23.16.0/20 और इसको आपने, you've broken this up into 8 blocks of /23. ठीक है? You could have broken this up into 4 blocks, ठीक है, of /22 or 2 blocks of /21. Or if you needed 16 organizations, you could have done this by having a /20, breaking this up into a /24. ठीक है? So is this clear, Ji? Any questions here? Okay. So this fly-by-night ISP has this block 223.16.0/20, and उसने क्या किया कि उसको it's broken this up into further 8 networks of /23.16.18.20 all the way .30 तक, ये 8 different networks के अंदर उसने इसको break up कर दिया. You have this other ISP over here, which is a 199.31.0.0/16. तो ये जो है इसको ये entire range 199.31 से जो चीज भी शुरू हो रही है, that belongs to this second ISP. Now, suppose we want to ask the question that how do entries in a router look like? ठीक है? And usme suppose what happens is that one of these organizations is what you call dual homed. It's connected to more than one ISP. Now, because it's connected to more than one ISP, ठीक है? तो basically हो ये रहा है कि ये organization 1 जो है, which is 200.23.18.0, ये इस ISP fly by night के साथ भी connected है, और इसका IP यही है, लेकिन ये दूसरे ISP के साथ भी connected है. Notice कि इसने IP जो लिया है वो इसका IP यही है, लेकिन connection इसका एक दूसरे ISP के साथ भी है. ठीक है? अब in this case, ये जो यहाँ पे route entry अगर है, which has send me anything with addresses beginning with this, that's perfectly okay, because you can route a packet जो कि इस prefix के साथ आ रहे हैं, and it's going to essentially get to any one of these organizations. So depending upon कि वो .16 है कि .18 है कि let's say if it was a .17, it would still go to this one over here. If it was a .19, it would go to this one over here. A .21 would go to organization 2. A .20 would also go to here, and so on. So the message that this fly-by-night ISP, the route that it advertises or the block that it advertises, कि जी मैं किस तक आपको पहुंचा सकता हूं, it's going to say send me anything with addresses beginning with this 200.23.16/20. Now, ये जो ISP है, this is connected to its original 199.31/16, but it's also connected to this other one, which is 200.23.18.0/23. Okay? So it can say, send me anything with addresses beginning with this, or beginning with this one over here, but this is a /23, so it will specify कि अच्छा ये block भी मेरे पास available है. I can route you to this particular block as well. ठीक है? Now, as you go up, how do entries in the router world look like? So basically, what you'll have is this is exactly what you'll have. That ये जो table है यहाँ पे, it's going to say कि okay, anything beginning with this, you're going to send to this particular fly-by-night ISP. Within the fly-by-night ISP router table over here, anything beginning with this is going to go to organization 0. Anything beginning with this is going to go to 2, and so on. Anything beginning with this is going to go to 1. Iske andar, you're going to have two things. Anything beginning with this or this. These two are going to be available over here. Ab yahan pe, if you have something like this, then what's going to happen is that over here, this ISP will say, send me anything beginning with this or this. Okay? Now, suppose that ये जो organization 1 है, it is no longer connected to this fly-by-night ISP. तो इसका IP address तो यही है, but it's no longer connected to this. So the question then is that, can this guy say that send me anything beginning with this address? And the answer is, can it say that? क्या ख्याल है? Any thoughts? No, very good. And the reason is that although बाकी सबको तो कर सकता है, 16 को कर सकता है, 20 को कर सकता है, 22 को, 24 को, 26 को, 28 को, 30 को, लेकिन 18 को नहीं कर सकता, ठीक है? So it cannot announce this for this particular /20 block. It will have to say कि अच्छा ये इनको मैं कर सकता हूँ, और 18 को जो है ना, it will not be able to aggregate or at this granularity. Okay. So how does the ISP get blocks of addresses? ICANN, IANA, the regional registrars, APNIC, country-wise, and that is how it's done. And all of these names and numbers are managed, and also disputes between these names and numbers are managed. So, for example, a long-standing dispute you have with .islam and .halal. Turkish company wanted to get these domains, and you had the IOC saying, "Nahi, we represent Muslims, so we cannot give this .islam or .halal to a Turkish company." So that's one of the most an interesting long-standing debate or dispute that you have in the assigning of domain names. So, because you have a limited number of IPs, okay, but it's limited by 32 bits, so 4 billion से ज़्यादा आप devices connect नहीं कर सकते. And long ago, यानी way back, maybe more than 10 years ago, ये जितने भी blocks थे, they have all been allocated to regional registries and to ISPs. So ठीक है, it's possible that within ISPs जो उनके पास blocks हैं वो सारे exhausted नहीं हैं. Individual ISPs may have blocks of IPs which can be allocated or leased out, but there are no new IP addresses there is no available pool of IP addresses जहाँ से आप नए IP addresses इस तरह से centrally allocate कर सके. They've all exhausted, and because of that, then you have something called a hack, which is network address translation, which allows you to use the same range, the existing range of IP addresses, उसको expand out करने के लिए और उसको sort of reuse करने के लिए, this is a very interesting translation that's done. Or the idea here is that you have a real IP, जो कि this is how you're identified on the internet, ठीक है? And then you have a local network. For example, it's a campus network or it's a किसी भी organization का अपना internal network है. It's a private network. And with this private network, you have a certain pre-specified sort of range of addresses. You can have 10 network, you can have a 192.168 network over here. इसी तरह से, these are the most commonly used private IP address ranges, and these ranges have sort of been standardized and specified कि अगर आपने private network बनाना है तो आप ये 10.0.0/24 इस तरह का नेटवर्क बना लें, या फिर 192.168 किस्म का नेटवर्क बना लें. 192.168 is a /16 network, so up to 64,000 hosts आप उसमें रख सकते हैं. यहाँ पे it's a /24 network, which means that you can have all the way up to 16 million hosts within a particular network. The LUMS network is a 10.0.0/24 network. जितने भी sort of local networks आप बनाएंगे, उन सब में यही range of addresses आप repeat करते जाएंगे. So these are sort of private IP addresses. They are not real IP addresses in terms of they're not globally unique. So everybody reuses the same set of IP addresses in their local networks. Okay? And these IP addresses are only valid for your local network or your home network. So if you look at your IP address at home, it's going to be a 192.168.something. ठीक है? इस तरह LUMS में आप किसी भी machine का host ID check करें, it's going to be a 10.something.something.something IP address. And wherever you go, you're only going to have typically a 10 network or a 192.168 network. ठीक है? By and large, these are the most commonly used sort of private IP addresses that you have. या फिर 224 वाला होता है. So therefore, you're going to be repeating all of these IPs within the local networks, and then you're going to be connected to the internet through a device, okay, through some gateway, through some proxy. And उस proxy के जो rest of the internet connection है, वो जो interface है, that's going to be a real IP address, okay, and that's going to be globally unique. So you have one globally unique IP address which connects the rest of the internet, and within your network, within your local network, you are reusing same set of private IP addresses again and again and again. Okay? So then what you need over here is network address translation, which basically maps a real IP address, जो कि आपका है for the rest of the internet, local IP address to behind this wall, behind this sort of, which is only relevant in your the local network. So the way it works is that because you can just use one IP address as far as the outside world is connected, and you can have, you have few IP addresses. You don't need to have a unique IP address for each one of the hosts that you have. You could have millions of hosts in a private network, but to the outside world, you will have just a few IP addresses for each of the interfaces that you have. And then, of course, you can change the addresses of the devices in the local network without notifying the outside world. ऐसा नहीं है कि outside world के अंदर जो भी आपके पास DNSs हैं, they have to be notified कि जी आपका जो है वो IP address change हो गया, and so on. So the ISP can also, you can change your ISP without changing the address of your devices in the local network. You can use that entire range locally, and that can be repeated across multiple networks. So the devices inside the local network are not explicitly addressable, or they're not visible to the outside world, which is a security plus. Okay? And basically you have a NAT router which basically replaces these outgoing datagrams. So जो आपका source IP address है, port number है, इसको it replaces with a network with a NAT IP address and a new port number, and it keeps a table, a network translation table. तो एक आपके पास WAN side है, which is the wide area network, which is connected to the real internet, और एक आपके पास private network है, which is your LAN side or local area network. So within the LAN, you've got, let's say, these different hosts, a 10.0.0.1, a .2, and a .3 host. This interface is a .4 host, and ये आपका real IP है, जो कि आप connected हैं through an ISP to the rest of the internet. That's a 138.76.29.7. Now, when you send a packet from this source to, let's say, to this destination, okay? So host 10.0.0.1 on the private IP, ये private IP है. How is it private? How do you know it's private? Because it's a 10 network. All 10 networks are private networks, जो कि यहाँ पे behind this NAT router बैठे हुए. So you send this from this source ID, आपका 10.0.0.1 है. This is your port number, and you're sending this to a server. Your destination is a 128.19.40.186. Web browsing कर रहे हैं, you're using port 80. So you send this datagram to that server. Now when you send this, okay, what happens is that on the WAN side, you're going to do a translation over here, and this packet, जो कि source, ये IP and ये port, as it traverses this NAT router, the internal IP address, your private IP address है, that is replaced by the public IP address. ठीक है? And इसका जो port number है वो भी change हो जाता है. So you have a translation table which does this mapping. So when this in LAN side address 10.0.0.1 port number this traverses here, आपने एक entry डाल दी, and you send this packet out with this new public IP address and this new port number. Okay. So the NAT router changes the datagram source address from the private one with this port number to the public one with a new port number and updates the table. जब वहां से response वापस आएगा, अब जाहिर है कि वो जो सर्वर था 128.119.40.186 listening at port 80, उसको packet ये मिला from this source. So it's going to send something back to this source, ठीक है? Which of course is 138.76.9.7. That is the interface of your NAT router. Now when this receives this, ठीक है, and notice कि ये जितने भी packets, जितने भी hosts यहाँ पीछे बैठे हैं, इनको जब it's going to send packets out onto the internet, it's always going to use this IP, this one IP. So you could have 10,000 hosts in this private network. To the public, only one address is visible. So you can think of this as one huge campus. जिसमें thousands of hosts बैठे हैं, NUMS network, but to the outside world, all you see is one IP address. But how do you distinguish between these different hosts over here? उसके लिए you're going to be using this port number. So ये जो table है, इसमें when the packet comes back with a destination of this particular port, this port number say you do the lookup using this port number, and you find out that ये packet was originally from this particular source. So you're going to then forward that packet to that particular source. Okay, so the network router changes the datagram destination from the real IP जो कि ISP यानी दुनिया के साथ जो connected है, and this 5001 port number helps the NAT router to identify which particular host this is meant for, and then forwards that datagram to that particular host. Okay. So in this manner, you can handle tens of thousands of hosts behind a NAT router. So you've got 16 bits for the port number, so almost 60,000 simultaneous connections with a single LAN side address को आप handle कर सकते हैं. Now this is controversial because ideally routers should only be processing up to layer 3. यहाँ पे आप उसके ऊपर चीजों को देख रहे हैं. You're violating the end-to-end argument in the sense के ये processing आप दरमियान में कर रहे हैं. It's not happening at the ends, and the NAT possibility, you have to worry about this because, so very good question. If someone from the WAN side wants to initiate a connection, then you have a problem because connection बाहर से तो you can do that to the NAT router, but internally whatever is behind this NAT router, वो सारे का सारा collapses into one IP. There are ways around that, and we'll talk about them. But directly आप बाहर से जो है ना इस तरह से connection जो है ना नहीं कर सकते unless certain things are sort of configured either in your NAT router या फिर कोई और तरीके आप इस्तेमाल करते हैं to make this possible. But because आजकल जितने भी networks हैं, you have to consider the fact that there will be NATs and most likely NATs होंगे. So you have to take them into account when designing P2P applications and other things, because this will mean that you will have both servers and clients potentially sitting behind NATs, okay? And उस case के अंदर you will have to circumvent NATs, and that is a problem. And you could 1996 say IPv6 has been standardized, okay? And IPv6 takes care of this problem of shortage of IPv4 addresses, but it's just the fact that IPv4 इतने बड़े scale पे already deployed है कि ये जो transition है from IPv4 to IPv6 24 साल हो गए हैं, it is still in the works. Okay, so just to address the NAT traversal problem, ठीक है? एक तरीका ये है कि so the question which was asked, Maham asked this question कि जी अगर बाहर client बैठा है और आपका server जो है किसी NAT router के पीछे बैठा है, so then how does this client know that how am I going to connect to 10.0.0.1? Because 10.0.0.1 is not a unique IP, it's a private IP. So how does it know कि अच्छा जी मुझे इस particular NAT router के को connect करना है, ठीक है? So this server address is local to the LAN. It can't be used as a destination address, and the only externally visible NATed address is this here. So एक solution ये है that you statically configure the NAT to forward incoming connection requests at a port to the server, at a given port to the server. So for example, if anything coming at this address on port 2500, that is always forwarded, for example, to 10.0.1 at port 25,000. So पहले से what you've predefined is you have a table entry over here that whenever you have something coming for this port externally, it's always forwarded to this port internally. Okay? But of course, उसका मतलब ये है कि this client somehow needs to have this information कि अच्छा मुझे अगर इस server को connect करना है, so I need to connect at this IP and this port, and then it can avail that forwarding entry and sort of this is called a hole. It can basically then go through that hole and connect to this particular server over here. So that's one solution. A second solution is universal plug and play devices, UPnP. उसमें ये है कि आपके पास you have a protocol called the Internet Gateway Device Protocol, IGD protocol, and what that allows for is a NATed host to learn the public IP address. So एक host यहाँ पे NAT के पीछे है, it's a NATed host. Using this protocol, it learns that what is the public IP address, 138.76.129.7, and it can add and remove mappings in the table, forwarding table, जिसके ज़रिए से someone from outside can then connect to here and get forwarded to here directly. So that is through the use of this IGP protocol. दूसरा तरीका है जैसे Skype इस्तेमाल करते हैं, that allows for network traversal and it uses something called relaying. अब relaying में ये है कि you have, let's say, a Skype client outside over here and यहाँ पे भी एक दूसरा client है और इन आपस में बात करना है. So what they do is that you establish a connection from this Skype client जो कि किसी NAT router के पीछे बैठा हुआ in a private network, ठीक है? So connection is to this relay is initiated by the NATed host, and इसी तरह से जब आप another connection is to the relay is initiated by this client over here, and then this relay does the business of actually establishing your relay connection so that you are connected through this relay over here from this client over here to this one over here. Okay? So that's how you have a bridging that takes place between these two connections, and that is how the connection is completed. So notice that when you're using a service like Skype, whether you're behind a NAT, आप भी Skype के साथ relay के साथ connect होते हैं, दूसरा client भी Skype relay के साथ connect होता है, and that is how through a bridging action the relay is established. The relay actually completes the connection between these two clients. So that's how a traversal can take place. So basically this one here is connected to somebody outside. This one here is connected to the same person outside, and they provide the bridging to complete the connection. Okay, so any questions so far? So Internet Protocol mein you've got ICMP, the Internet Control Message Protocol, related protocol hai jo ke control messages ke liye istemal hota hai. And you can view this as something above layer 3. It's classified as layer 3, but essentially ye jo messages hain, they are encapsulated in IP datagrams. So these messages, because they're carried in IP datagrams, just like TCP and UDP messages or segments, because they provide network information, and typically जो routers हैं वो ये packets generate करते हैं जब कोई मसला होता है. For example, error reporting है, आपका packet जो आया है that let's say its destination is unreachable, ठीक है? So ICMP message is going to be generated by the router and sent back to the source. इसी तरह से, for example, आपका time to live TTL जो है वो expire हो जाता है. So you know that the TTL field is decremented by 1 at every hop. Let's say it gets to 0 before the packet gets to your destination. So जिस router पे वो 0 हुई है, वो router एक ICMP packet generate करेगा and बताएगा कि ये packet यहाँ पे जो है ये expire हो गया है, and it specifies कि मेरा IP क्या है, मेरा IP address क्या है जहाँ पे ये packet TTL उसका 0 हुआ है, and it sends that back to the source. So that information is received by the source. It knows कि अच्छा इस IP address के ऊपर जाके आपका time to live जो है ना वो 0 हो गया, ठीक है? And so on. And so you've got two fields over here, a type and a code. And the type field and the code field together, they specify कि किस किस्म का control message है. And so for example, if it's type 0 code 0, that means it's echo reply, it's a ping message, ठीक है? If it's destination network unreachable है, destination host unreachable है, protocol नहीं है. इसी तरह से if you've got the TTL expired, or if you've got things such as the destination host is unavailable or unreachable, uska bhi there is a message, ठीक है? So it's a simple message which the type, code, and you also have the first 8 bytes of the IP datagram causing the error. उससे आपको पता चल जाता है कि what particular datagram caused this particular error. Now, this ICMP is used for a very interesting app, छोटी सी जो I should say utility called Traceroute, which was there in the as part of the OS operating systems, Unix and so on. And usme basically what you want to do is if you want to trace the route from one host to another host, so you want to find out कि along this path क्या IPs interfaces के क्या IPs हैं, ठीक है? So how can you do that? Well, you can do that by sending a series of UDP segments to the destination, and these are carefully crafted UDP segments. ठीक है? The first UDP segment has a TTL of 1. Now, because पहले segment का TTL 1 है, तो जो ही उसने पहला hop traverse किया, इस router ने TTL को decrement किया, and TTL x 0 हो गया, time to live 0 हो गया, which means that that particular datagram has expired. Now, because the datagram has expired, it's going to create an ICMP message back to the source, specifying कि ये कहाँ पे expire हुआ. So if you set the TTL of the first segment to, or the first set of segments to a 0, and you send 3 segments, for example. So then and if you started a timer over here, you would figure out कि अच्छा कितने time में ये पहले hop पे ये चीज expire हुई, and इसका क्या IP address है, an ICMP packet is sent back by the router to the source specifying that. तो उससे आपको ये पता चल जाएगा कि अच्छा ये one hop away जो router है उसका क्या IP address है. इसी तरह 2 hops away जो router है उसका क्या IP address है, 3 hops away जो router है उसका क्या IP address है, and so on. Now the UDP packet contains an unlikely port number, which means that it's a port number which is not being used. ठीक है? So ultimately आपका जो IP packet है, it'll get to the destination, and once it gets to the destination, because that is the destination that you wanted to get to, but because it has an unlikely port number, then you're going to get an error back, an ICMP packet back, which is telling you this is a unreachable host, sorry, an unreachable port number at this destination. Okay? So basically what you're doing is by transmitting probes, first with the TTL equal to 1, you're getting back the round trip times as well as the IP address of this particular router. फिर आप 2 hops का भेज रहे हैं, and because you're transmitting these 3 probes, they go TTL यहाँ पे 0 होगा, so this is sending you back an ICMP packet जिसमें ये बता रहा है कि यहाँ पे ये packet expire हुआ है and मेरा ये IP address है. फिर आप 3 probes भेज रहे हैं जिनका TTL 3 है, वो सारे के सारे यहाँ पे expire होंगे. आपने उनका average round trip time निकाल लिया, so you know कि अच्छा how long is it taking on average to get to here, and what is the IP address of this particular interface. So इस तरह करते करते what happens is that you will be able to trace the entire path hop by hop to the destination, and at the destination, of course, your ICMP message will be KG port unreachable hai. Okay, so that's the stop criteria. The UDP segment eventually arrives at the destination host, and the destination returns ICMP port unreachable, which is type 3 code 3. And usse pehle, when these TTL expire ho raha, you have a type 11 code 0 message being sent back by each one of these intermediate routers. Okay? And that is how you can trace the route. Okay? It's an interesting thing. You can try it out, tracing the route to a particular IP address, and it's a very interesting thing. You get a list of all of the intermediate IPs to that particular destination, and the way it's actually done is through ICMP packets, which are returned by these carefully crafted UDP messages with a incrementing TTLs, and because they're going to expire on the way, so that is how you figure out के रास्ते में कौन-कौन से routers exist करते हैं. Any questions here, जी? Yeah. ICMP limited to UDP नहीं है. देखें, ICMP is a separate protocol, ठीक है? So जैसे कि IP की payload में TCP segment हो सकता है, UDP segment होता है, and ICMP is a special protocol which provides you this control information. ठीक है? The ICMP packet, it has this type and code, and ये बताता है कि जी जब भी कोई मसला होता है, an ICMP Internet Control Message Protocol sort of ICMP message जो है ना, that is sent back to the source wherever a problem takes place. So it's basically constructed by the routers, and वो एक message भेजते हैं to the source. ठीक है? So it's not UDP, it's a different protocol, it's ICMP. Trace route के लिए it is used in, यानी basically what you're doing is you are sending out UDP probes. ठीक है? And because these UDP segments have a TTL of 1, 2, and इस तरह से आगे चलते जा रहे हैं, so ये TTL 1 वाले यहाँ expire होंगे, TTL 2 वाले इधर expire होंगे, TTL 3 वाले इधर expire होंगे, ठीक है? And expiry के response में an ICMP message is going to be sent by the router back to the source. ठीक है? So आप UDP segments भेज रहे हैं, पहले 3 भेज रहे हैं with the TTL 1. ये यहाँ पे जहाँ पे expire हुए तो आपको 3 ICMP messages ये router भेजेगा in response to those TTLs expiring here. फिर in response to those UDP segments expiring here. फिर आपने 3 भेजे UDP segments with a TTL equal to 2. वो 2 hops पे जाके expire हो गए, and ये उनके response में ये router at each expiry of a packet ये router 3 ICMP messages आपको वापस source पे भेजेगा. ठीक है? So this is how it's going to take place. So this is how it's going to take place. ठीक है? So you're sending 3 UDP probes, they get expired. So probe expire होते हैं at the router is sending you back the ICMP message. ठीक है? And by receiving those ICMP messages, you are receiving the IP addresses of these interfaces. And ultimately जो यहाँ end तक पहुँचेगा वहाँ पे you will get this UDP segment पहुँच तो जाएगा, but because once it gets here, there is no process running which corresponds to that port number. So you're going to get an ICMP port unreachable message from the last machine back to you. And that is how you'll know, because that is where you wanted to find out जहाँ तक path निकालना चाह रहे थे उस interface से, तो उस host से आपको एक ICMP port unreachable message मिलेगा, and that is going to be your last hop. Okay? Any questions here, Ji? Okay, so the question is that can't routes change in the middle due to congestion, etc. They can, but ये routes change होना is not such a instantaneous thing. ठीक है? You could have a route failure, लेकिन जब आप एक sort of यानी trace route कर रहे हैं, तो in that यानी you know, in all probability आपके पास वही path sort of trace out होगी, unless कि उसी time पे एक network failure हुआ और बीच में एक route crash किया, and then you routed around that failure. The likelihood of that happening is very small. ठीक है? इसी तरह से although in theory congestion की वजह से आप यानी you could be following a different path, but routing your forwarding tables होते हैं, they are relatively यानी उनके जो time scales हैं वो ऐसा नहीं है कि forwarding table every few milliseconds microseconds update हो रहे होते हैं या instantaneously congestion को वो respond कर रहे होते हैं. The time scales are much slower. Changes happen at much slower time scales than than an individual sort of connection or a flow. So although it's not connection oriented, it's connectionless, hop by hop चीजें जा रही हैं, लेकिन ऐसा भी नहीं होता कि हर पैकेट ही different path ले रहा है. Okay, so IPv6 is the solution, or the motivation behind IPv6 is that instead of using 32-bit address space, we use 128-bit address space, and we use a fixed-sized header of 40 bytes. TCP header, as you know, is 20 bytes. यहाँ पे एक fixed-size header है 40 bytes का, and it's very similar. You have the first bits identifying the version. So by looking at the first bits, you know कि version 4 है, version 6 है. अगर version 6 है, तो आप remaining bits को उस तरीके से decode करेंगे. Then you have the priority. So this identifies priority among datagrams within a flow. So there's this concept of flow. 20 flow label hai. And what is a flow? It could mean different things. It could mean connections belonging to the same voice or IP or video stream. They could have the same flow label. So that's the concept of flow. It's typically not the same email address or not the same sort of TCP connection. So this has been sort of left open कि अच्छा flow को कैसे interpret करेंगे, but the concept is that we will have a flow, and the flow label over here allows you to identify bits belonging to a certain flow. The payload length is 16-bit field, which specifies that आपका जो payload है वो कितने bytes का है. So you can have a 64 kilobytes payload. Then you've got next header, which specifies कि जो payload है वो कौन सा protocol carry कर रहा है. TCP है, UDP है, कुछ और है. You don't have option fields, but potentially you could use this next header for options. ठीक है. And the great thing here is that you also have TTL, hop limit, वही चीज है यहाँ पे. And then a source and a destination IP. Notice ये 128 bits हैं, so essentially these are like 4 words of 32 bits each. So यहाँ पे, although, so you can think of these as 128 bits of source address and 128 bits of destination address. There is no segmentation reassembly over here. ठीक है. So अगर ये कोई packet जाएगा and बीच में से if it's dropped, then an ICMP message back to the source for ICMP version 6 will tell the source कि ये चीज drop हो गई है, and therefore you need to use a smaller size for the MTU, maximum transmission unit. But just to simplify things, there is no fragmentation reassembly. And it's a fixed length header, 40 bytes ka header hai, and it's very fast to process, and it provides you 128 bits of addressing, which means 2 to the power 128 or more bits than the grains of sand on the entire planet. So with this, there is no shortage of address space, and वो सारे मसले netting वगैरह, you don't need them. You can work. उनकी ज़रूरत ही नहीं है. So it's really wonderful. लेकिन मसला ये है कि the problem is that because it is अभी it's still adaption इसकी इतनी नहीं है. You have a lot of IPv4 devices, and so you can't have a flag day which says अच्छा इस तारीख को if we will shut down IPv4 and everyone will move to IPv6. That is not possible. We've tried that 20 years ago with another protocol when we were moving to TCP, ठीक है, but we found out कि ये एक दिन पे करना is really difficult. There are so many billions of legacy devices कि उन सबको एक तारीख पे map over करना is just not possible. Y2K के सिलसिले में भी इसका flag day try किया था, but there are many challenges. So what will happen is that routers will operate with both IPv4 and v6 that they called dual stacked, और फिर आप tunneling करेंगे, which means that an IPv6 datagram is carried as a payload in an IPv4 datagram, and we'll talk about this inshallah in the next lecture. Okay, so any questions here? Any questions? ठीक है. Okay, so thank you very much. So.